morning, everybody. Guess what? Today we're going to talk a little bit more about density. Now, I'm sitting out here in my pool. It's a little bit of a hot day, but I just thought a glass of water and some of my friends might be a great way to try to talk about density today. So, have you ever wondered why certain balls will float? Why do boats float? Why do some people float? Why do ducks float? And then some objects sink. Let me talk to you about some of the things I've brought for us to experiment with today. These are some items that you're going to need to do this at home. Okay, first thing is I have a glass of water, and you'll notice that I marked the top of the water line with a little blue piece of tape. Any kind of balls or objects that you want to try out would be fine. Today I decided to bring in little balls. I brought myself a tennis ball. I want you to see that. Brought myself a stress ball, which I've been using quite a lot. I've used a wiffle ball. Now notice the wiffle ball's got some holes in it, okay? I also have a golf ball, a ping pong ball, a marble, if you guys can see that little glass marble, and last but not least, a little magnetic metal ball, okay? So my goal is going to be find out and try to predict which ones are going to sink and which ones will float. Now, I'm sitting here in my pool. As you can tell right now, what's going to happen if I fall back? I know if I go down, whoo, it is cold. But if I were to lay back in it, do you think I would sink or do you think I would float? Hey, I'm back again. I'm excited. We're going to kind of figure out a little bit more about density. Now, density has to kind of do with the makeup of an object and kind of how much water it can displace. Now, I know you're wondering, what's displacement? Okay, I'll tell you a little secret. Displacement is the amount of water, we call it water displacement, that can actually be displaced or moved around because an object goes in there. So let me ask you guys a question. When you go into a bathtub, what happens to the level of water? Well, I'll give you a hint. When I got into this pool was really smooth and nice. And then I got in it and I just noticed the level went up just a hair. Now, it's not because I'm big. It just has to do with I displaced amount of water. And I happen to be more dense than water, and that could be why I sink. So what we're going to do today is we're going to take a look at two different balls, okay? Both of these are pretty close to being equivalent in size. In weight, not so much. The golf ball's a little bit heavier. The ping pong ball's a little bit lighter. But they're about the same. Now, my prediction is they're both going to float. What do you think's going to happen? Well, how about you hold on and let's try to guess. Right now I'm going to have you predict. What do you think is going to happen? Okay, I'm back. A little breeze kicked in. We're going to test out the ping pong ball, but don't tell anybody. We're going to try this ping pong ball. What do you predict will happen when I put it into the water? Let's find out. Ready? I'll move this up closer. Watch that water level. Oh, what did you notice? Looks to me like it's floating. Let's look very carefully at it. If you look at the water line marked by that blue piece of tape right there, it doesn't look like it displaced or moved a lot of water, although the water level went up a little bit. So what that says is that my ping pong ball is less dense than the water. And because it is less dense, that means it's able to float. Now, I wonder why it's floating. Do you guys have any predictions? What do you think might be contained in that ball to make it float? Because that's going to help us understand a lot of stuff about density. All right, guess what we're going to do? We're going to grab this golf ball, pretty much the same size. What do you predict is going to happen with the golf ball? Going to get ready to drop it in. What do you think? Here we go. Oh my goodness. Oh my goodness. Will you take a look at this? Look at the golf ball and look at the level of my water. Do you notice the level of the water we started right here? Did I just grow water? I didn't grow water. What do you think just happened? What happened is this golf ball weighs more than the water. So it is more dense than the water. And when things are more dense than the liquid that they are going into, and it can be any liquid, it's going to sink. Okay, so unfortunately, this poor golf ball is at the very bottom. But look what happened. You can see the level of displacement, how much water was moved or displaced because of the weight of this. All right, now hold on. We're going to check out some more stuff. Let me go get some more swimming in. Hi, you guys, I'm back again. Today I'm kind of excited because we're going to try to figure out what matter makes up an object. Everything matters. I'm sure you've heard that before, but really everything is matter. And every piece of matter is made up of different objects or molecules. So like we said before, every object is made up of molecules. We've all heard about solid, liquid, and gases, right? Okay, well, solids have a whole bunch of molecules that are just packed together and there's no room for them to move, and that's why things become solid, okay? Kind of like this rock. This rock is solid. You probably see rocks all over the place. It has a bunch of molecules inside it and outside of it, but they're all packed together and they can't move anywhere. That's why it's called a solid. Other things sometimes have liquids like this. I brought some oil with me, okay? Liquids have a bunch of molecules that are constantly moving all over the place, all right? So this is also matter, and it's something that we can use with water, okay? It's also a liquid because the molecules are moving all over, all right? Then we have something called a gas. Now, I can't show you a gas. Gas can be in helium. Gas can be in the air. You know, sometimes we're breathing. The oxygen is part of a gas, okay? So that is free falling all over the place. You probably see air everywhere you go. Where do you think those molecules, do you think they're stuck in one area? No, they're not. They're flying everywhere. So those are moving all over the place, which that makes it a gas. It doesn't make it solid where it stays in one place. It makes it a gas. So again, we have something that's solid, like a rock. We have liquids, kind of like water, oil, soda, okay? And then we have gases, and most of the times you cannot see gas. Sometimes you can smell it, but we'll call oxygen a type of gas. Hydrogen, okay? All right, so what we're gonna do today, in one moment for a moment, I have a bee in the pool, and I love bees, but we're not studying bees today. Go away, bee. All right, maybe it's a spelling bee. Okay, so what we're gonna do today is we're gonna talk about a few objects. I brought an apple. I love apples. I wanted to show you an apple. I got in a lemon, all right? I brought my rock that I showed you. It's a solid rock. I brought another kind of rock. I want you guys to look really closely at this one. This is called a pumice rock, or a pumice stone. It comes from a volcano. Notice there's a lot of holes in it. I brought a balloon, okay? I brought a wrench, okay? Sometimes this is used to repair items. I also brought a cork. You've probably seen corks when you've seen like a message in a bottle. The pirates used to leave them out there in the bottles, okay? And then I brought a piece of wood. I brought a flat piece of wood and I brought a block of wood, okay? So I want you to notice that everything I'm showing you is a solid, okay? Wood is solid. This piece of wood is solid. This cork is solid. This apple is solid. This lemon is solid. The balloon is solid because it's made of some material that makes it stretch, but it's solid. The wrench is solid. And the rocks. Okay? I just want you to be able to hear it. So now what we're going to try to figure out is which one sinks and which one floats. Hope everybody can see this. This is a little measuring tool. I can measure in grams or I can measure in ounces. But today what I'm going to do is I'm going to measure in grams. All right. The first thing I thought I would do is show you this solid rock. All right. I want to explain to you that I'm going to measure this rock. And let's find out how many grams this rock is. All right. What do you guys notice? Looks like it says 159. Is that 159? Sorry, 154 and 4/10 grams. Some people would say 154.3, but we're going to say it properly in math. It keeps changing. 154 and 2/10. Sometimes that adjusts, okay? So try to remember that number. 153, 154, we'll stay around there. All right. The next thing that we are going to do is we're going to actually take this pie pan, okay? Now, the reason I'm taking this pie pan is I'm going to put it on here, and you're going to notice the pie pan actually weighs something. It weighs about 12.5. So what I'm going to do is I'm going to zero this out, and we're going to pretend this pie pan weighs absolutely nothing, okay? So let me put that rock back on. Now the rock weighs... Oh, it changed to ounces. Let's go back. There we go. About 154 let's give or take, let's just say about 154, okay? We zeroed it out, so now that pie pan doesn't matter, okay? So 154. Now what we're going to do is, you see this glass of water? Okay, let me show you what I'm about to do. I'm going to fill it up with water right now, all the way to the rim. Okay, can everybody see that it's filled to the rim? Now, very carefully, I'm going to put this inside the pie pan. Now, it's filled to the rim, so I don't know if you guys can see right up here. It's literally at the very top, okay? Now, we're going to look and see if we can find out if this rock will displace. Remember yesterday we talked about displace. Displace means to leave or jump out. You know, take away. And I'm going to drop this rock in here. I want you to see what happens. What do you predict will occur? What's going to happen when I put this rock into the bottle or the glass of water? Remember that we talked about what happens when you get in a bathtub? What happens to the water? You thinking? Okay, here we go. Let's watch very carefully. Uh-oh, what are you noticing? Uh-oh, did you see that? Not only did the rock sink to the bottom, which says it is more dense because it's heavy, it's more dense and it went to the bottom, but I want you to look. I'm going to remove this really quick. Whoops. Okay, if you look at the bottom of this pan, I'm going to move it for a second. Look at this. There's water. That's the water that got displaced. So if we can look down here at our scale, it says it's 47 point, let's just say 40 something grams, okay? That's how much water was displaced by this rock, all right? Which means that rock weighs more, that was able to push the water out. Kind of like when a boat is sailing. You wonder where those big Carnival cruise lines, how come they're sailing? That's a good question. Why do those boats sink? Why do the boats still float? Well, here's the thing. The Carnival cruise ship floats because the weight is less dense than the water that it displaces. And I know it's hard for you to see it because I can't measure all the water out in the middle of the ocean, but that ship, believe it or not, and it has to do with surface tension, which we're not going to talk about in the surface area, but it actually is less dense than water, but there's a lot of water out there in the ocean. So I just wanted to show you first this displaced water from the heavy, heavy rock, okay? So I'm going to say goodbye to the water. We're going to put our pie pan back on here. I'm going to zero it out again. There we go. And I'm going to get my rock out, okay? We're going to try this again. There's a full glass of water. And this time, let's find something else we could do. Let's try a lemon, okay? Let's weigh the lemon. Oopsies, how much does the lemon weigh? It says about, let's say about 102 grams, okay? So now what we're going to do is I want you to watch. We're zeroed out again. I'm going to put this glass up here. And notice it's filled all the way to the rim. I want you guys to be able to see that. See? Right? Top. I'm going to take this lemon. Now, first of all, let's predict. Do you think it's going to sink or do you think it's going to float? It's a lemon. I don't know. It looks like a solid to me. What do you predict? I don't know. Let's see what happens. Here we go. Let's watch for displacement. Let's see what water comes out and gets displaced. And then let's see if our lemon sinks or floats. Uh-oh. Who knew? The lemon is floating, but it did also displace water. Look at that. Okay. So now we've got to figure out, why did the lemon float? What about that makes that lemon float? That's something that we need to talk about today because this is the magic of some of our objects that we're working with. This lemon is floating. Even when I push it down, it's still floating. Why do you think it's floating? Okay, now I'm going to do something kind of risky. I'm taking you in the pool with my laptop. Do not do this at home. I think it's just the fear of me dropping this laptop is going to make me hold it that much tighter. So I'm going to bring a few objects into the pool with me. First thing I'm going to bring is a lemon. Well, we already know what we found out about lemon. Uh-oh, do you see it? It's sinking, okay? What do you predict will happen with an apple? What do you predict is going to happen with an apple? Let's try. Ready? Okay, now, where have you seen apples float before? Let me try to zoom in on this. Where have you seen apples float before? Maybe when you're bobbing for apples. Have you ever done that before? But why is an apple and a lemon floating when they're both solids? Doesn't make sense. I'm trying to think what might be in there. Okay, so let me keep those in a little area. We're going to try another one. All right. I want you guys to watch this rock that I'm about to drop on the steps of my pool. Here we go. Ready? Uh-oh. Where did it go? It's down at the bottom. Okay. Now hold on. I've got another one for you. Let me get my rock back here. Okay. Hopefully everybody can see this. Now we're going to try this other rock. This is called a pumice. Ready? Oh my goodness, what on earth? Why is that stone floating? We're going to talk about that in a minute, okay? We're not quite done. I've got a block of wood. Does wood float? I don't know. Let's find out. I'm going to plop this up here. The wood is floating. Okay, now I want you to look really carefully. There's some little bubbles over there. It looks like there's some air in there. I've got another piece of wood. This one's a little bit flatter. Let's see what happens with that one. Look at that. That one's floating as well. Let's try the cork. Can you guys see the cork? Let's try the cork. A cork is floating. And I'm going to try one more object. This is the tool that I showed you. Ready? We're going to drop this down. And let's see what happens. What do you predict is going to happen with this? It's a solid as well. It's a metal, though. This solid, do you think it's really solid? Do you think the molecules are moving in it? Let's see what happens when I drop it. What just happened? It sank. Okay, I want you to look at all these objects. I'm going to bring them all back here. We've got a lemon. We have pumice. We have a cork. Why are these objects floating? Can you predict?
You ever sitting by the pool and you're like, gosh, I am so thirsty, but you don't want water, you want something different? Well, I got you. Have some root beer. You can mix it with vanilla ice cream have a root beer float. Or if you're feeling kind of weird, you could throw it in the pool and literally have a root beer float.
Do you remember we were trying to figure out why certain objects were floating and the other ones weren't? Well, let me tell you something. If you didn't know this, air is less dense than water. Air is less dense than water. Air has oxygen. I wonder what that means. So let me take a look. Let's take a look at this one pumice stone. This is a rock, comes out of a volcano. It cools really quickly, so it gets all these air bubbles trapped in it. I don't know if you can see all those, okay? This is an igneous rock. It came from a volcano as well, but it heated very slowly, so it had time to form, and you can just feel how hard it is. All those molecules are in there, and they're just stuck together. They're very, very solid. But again, this one cooled really quickly, and it left a bunch of, we'll put air pockets in there. So air, solid. They're both solid, but which one would you think would float? Well, we saw it earlier. The pumice floated. And why did it float? What's less dense than water? Air. Okay, so I want you to remember that. All right. Now let's talk about this cork. This cork that you would find in a message in a bottle. Okay, I want you to kind of look at the cork. I'm going to try to come up really closely. You see those little crevices in there, little air pockets? There's a little air pockets in there. Look at all that air. So I wonder, do you think that might have something to do with it? Something to ponder, okay? Think about it. Does this have air in it? Even though it's a solid, there's some air in here. And remember, air is less dense than water. Now, the big question. This really baffled me. I remember playing that game of dunking the apples, bobble, and you'd have them float in the water and you'd try to grab them with your teeth. Well, why do you think this floats? Listen to that. It's solid. What do you think might be inside? Well, I'm going to show you. Okay, I'm going to cut this apple open. And again, don't do this at home unless your parents are with you, because I kind of feel like knives can be a little bit scary. But I'm going to show you the inside of this apple, okay? Inside this apple, it looks very solid, right? But there's some little cells in there. You can see the little openings where some air might be trapped. So let me cut down to the core. Aha! There, now I can show you inside my apple. Do you see any air pockets in there? There's some air pockets in there as well. So if some of my apple has got some gaps in there that contain air in the molecules that make up the apple, do you think that has anything to do with it? Something to ponder, okay? Now hold on, I have to have an apple bite. Oh my gosh, I love apples. Okay. Oops, sorry. Now I have a balloon. What should I do to this balloon to make it float? All right, what would you do to a balloon to make it float? Come back and let me know. What do you think is going to happen? Taking another chance again. Take you out to the pool. Here we go. Drop my balloon in. It's floating. And what do we learn today? What do we know about why my balloon is floating? What does it have inside, trapped inside it? What does it have trapped inside? Air. Okay, so that's part of the reason a balloon might float. Can you think of some other objects that can float in water that might have air in them? Let me know. Because the first question we had when we first started this video is, why is Mrs. Peck floating? Trust me, I have tried jumping in the water, and guess what happens? I go way down. Depending on if I have air in my lungs, if I have air in my lungs, I can come back up. But if I just go down, I will sink to the bottom. So why is Mrs. Peck floating in a boat? I'm having so much fun. Okay, here's the deal now. We studied and practiced using some solids, and some solids floated and some solids sank. And then we realized that sometimes some solids have got some air in there. Those molecules, even though they're solid, have got some little gaps of air, which would cause it to float. Because remember, we talked about air is less dense than water. So it's going to float, all right? So I want to show you a couple of liquids that I have. I brought some olive oil. That's great for cooking. And that's a liquid, okay? And then I brought some food coloring, and I got blue because I figured it would match with the pool water. So what I want you to do is I want you to look, and I'm going to move this up a little bit. See if you can tell me, what do you predict is going to happen when I take this liquid? Now remember we talked about molecules moving around in liquids, maybe not as freely as gas, but they do move around a lot. What do you predict is going to happen if I put a drop of food coloring in here? Do you think the food coloring is less dense and will float, or is it more dense and it will sink? All right, let's try it. Ready? Here we go. Let me move my arm out so you can watch it. What do you notice is happening? It's kind of making a really great picture for us. But I'm noticing that the droplet is sinking. So if you see the color sinking, what does that tell you about its content? Is it less dense or more dense than water? If it sank, look at the bottom. When we come up close, see the majority of the food coloring is at the bottom. It looks to me like food color is more dense than water, so it sank, and then I can just swirl it around and make some pretty blue water. Okay, so now I have some blue water. Now we're going to try something else. Let me discard this in a safe pan. All right, I'm going to get some more pool water. We're going to try something different. All right, one moment please. All right, now I have a fresh glass of water, all right, from the pool that I will not drink. We're going to try this liquid. This is olive oil. All right, what do you predict will happen if I put the liquid in? Do you think that the liquid olive oil is less dense, meaning it'll float, or more dense, meaning it'll sink? What's your prediction? Okay, let's try it. Here we go. I'm going to come over here. Oh, look at that. Look at that. It looks to me like it's floating. If it's floating, that must tell you there that it is less dense than water. So water and oil, you've probably heard, don't mix. If you've ever had Italian salad dressing, the oil is always at the top, so you end up wanting to stir it up. So if I stir this up, let's see what happens. What happens to all the oil? It's less dense than water, so it's going to go back to the top. Kind of an interesting little tidbit, but now oh my gosh. Okay, so I've got kind of just a great thing to do right now. And we're coming close to the end of this whole thing about density. So far today, we've talked about density and water displacement. Density happens to do with if it's less dense or more dense than water. So if it's less dense, it's going to float. If it's more dense, it's going to sink. Okay, we also talked a little bit about solids, liquids, and gases. Solids, all the molecules, everything's made of molecules, but they're tightly packed in, so there's no place for them to move, so they make them really hard, a little more dense, and they usually sink. Then there's liquids. Sometimes liquids, the molecules are moving a little bit more freely, so depending on the density of the liquid, it may sink or float. Remember, the oil floated and the food coloring sank. And last we talked about gas. Gases, you really can't see them. They're all over the place. But those molecules are moving around freely all the time. They're having a party. So blew up a balloon. And what happened with the balloon? It had air. Air is a type of gas. So it floated, okay? And then we realized that sometimes some objects like the pumice stone had some air pockets, and even apple, the one that I bit into, has got some air in the solid, so it helps it to float, okay? And why does wood float? That was another question. Look at the wood very carefully. There are actually air pockets within here, and that air helps it to float. Could be part of the reason some people make boats out of wood. But last I decided this rock is very solid. There's no way that any molecules are having a party in there. But how could I make this rock float? Well, here's what I decided to do. I found some bubble wrap. I don't know if you guys have some of this running around, but what does bubble wrap have in each of these pockets? Listen carefully. Well, maybe not. Ooh, sounds like fireworks, which are illegal, so don't use those. But these have little air pockets. So I was wondering if I took this bubble wrap and took this heavy, heavy rock and I put it on here, and then I decided I was going to wrap it up with some tape. So I'm going to bubble wrap my rock. Okay, so let me bubble wrap my rock. Wrap it up, make it all tight. I just wonder if this might make my rock float. Okay, so I want to make sure you guys see my rock inside there. You see that rock? All right, so we're going to go take my laptop into the pool again. Keep your fingers crossed. Let's see what happens. Here we go. Here we go. My rock is in here. Look at my rock is floating. Ah, I'm so excited. The rock is floating because why? Because there's air trapped in the bubble wrap that's keeping my rock afloat, which made me start thinking, why does Mrs. Peck float? What is keeping her floating? Okay, had one more question. Found this sponge. See the sponge? Sponge has got a lot of holes in it, which mean it's a solid. But there's a lot of holes in here which have air. So, here's a question for you. How come Spongebob SquarePants is at the bottom of the sea? It's really bothering me. Because I want to show you what's going to happen if I take this this wonderful sponge, and I put him in the water right now. Let's see what happens. Watch the sponge. It's got air, so I'm going to decide it's got to float, right? Because SpongeBob doesn't. Okay, what are you noticing is happening? It's getting wet, but is the sponge still floating? Okay, this doesn't make sense to me. So, back to my question, why is Spongebob SquarePants at the bottom of the ocean? Okay, we got to figure out why Mrs. Peck floats. So keep your fingers crossed that the laptop doesn't fall in, but I'm going to crawl into this boat. Oh no! Here we go. Oh, I'm in right now. Oh my gosh. Okay, here we are. Guess what? We're floating. How did that happen? If I jump in, this normally doesn't happen, but I'm actually floating. So what's making me float right now? What do you guys think? What have we talked about? Well, first of all, I know that I am more dense than water, so I should be at the bottom of the pool. But I'm sitting here in my pretend boat, and I'm floating. What does that boat have inside of it? Air, okay? It's the air. So the more air I have, it's not going to displace as much as much weight as I would. So right now the air is less dense than the water, which is helping me float. So there you go. There's the answer to your question. Why does Mrs. Peck float? Thank you to the boat, thank you to science, and thank you to the magic of density. Air is much less dense than water, which lets me float. So for the rest of the day, I'm just going to kick back here and think about you guys and hope you can have some fun too. Because I want you to try this at home. Try to find some things that are less dense, more dense, that can float in the water. You can use your bathtub, you can use a sink, you can use a pie pan, you can use whatever, but just have some fun and get back with me and let me know how it goes. Okay? Until then, keep floating. Love you guys. Bye.